Hi, welcome to uh, analysis of this RL network. So let us consider this particular problem where we are asked to find what is the expression for this current flowing through this inductor. So we are asked to find what is this IT. So we know that the current through this inductor at any point of time is given by the initial current, that is, we of course it can be written as I infinity plus of I initial minus I infinity into e power minus t by tau. So where tau is given by, where tau is a time constant which is given by L by R. So first let us try to find out what is this I naught. I naught is nothing but the current that would flow in this 20 millihenry inductor when the switch is in position 1. So because at t is equal to 0, the switch is moved from position 1 to position 2. So I naught is nothing but it is the current that would flow in the 20 millihenry inductor when the switch is in position 1. When the switch is in position 1, we have this as the equivalent circuit. So the circuit will look like this now. So it is now, this is the circuit. So this is 50 volt, this is 40, and this is 20 millihenry. So we know that whenever it is there in this condition, so because this is 50 volt DC and this acts like a short circuit, so I naught you can treat it as, or I naught will be equal to 50 volt divided by 40 ohms, so which will be equal to 5 by 4 amperes, which is nothing but 1.25 amperes is the value of I naught. This is when it is in, when the switch is in position 1, which is the initial condition. When the switch is moved to t is equal to t is equal to 0, the switch is moved from here to here. Then the circuit will change to something like this. Now you have, this is a circuit. Now the voltage is 10 volt, and you have same 40 ohm resistor. You have a 20 millihenry inductor. Now I want to find what is I infinities. So I infinity is nothing but, okay, this is when t is far greater than 0. Under that condition, we know that I'm going to have 10 volt power supply is coming in series with this network. So this I infinity, so for any time far greater than uh, 0, so this acts like a short circuit. Then I infinity will be 10 volt divided by 40 ohm. So this will become 1 by 4, which happens to be, so now I infinity is equal to 0.25 amperes. Now we know what is I naught, we know what is I infinity. Now I need to know the value of tau. So tau is that value of L and R when the value of t is greater than 0. When greater than 0, you have this as the circuit diagram. Then the value of tau will be equal to, L is now 20 millihenry. Now R is equal to 40 ohm. This is 40 now. So if I want to write the exact value for this expression, so now it is I of t is equal to, what is of course it is I infinity plus of I naught minus I infinity into e power minus t by tau. So I know I infinity is 0.25 plus this is 1.25 minus 0.25, which happens to be 1 e power minus t. Of course, what is now 1 over tau? So 1 over tau is actually is equal to 40 divided by 20 millihenry, or this is of course this will become second. So then this will be 4 by 2 milli, then this becomes 2 kilo. So now this is equal to 2000. So the expression for I of t is now given by I of t is equal to, I of t is now equal to 0.25 plus e power minus 2000 t. This is the expression for I of t for this particular problem. Okay, let us move on to next problem and try to find out what is the current through this. So here we are having at t is equal to 0, the switch moves from uh, position 1 to position 2. So let me again write what is this. I of t is equal to, I of t is nothing but let me just put it here. It is now again I infinity plus I naught minus I infinity into e power minus t by tau. So let me first write what is I naught is. I naught is nothing but when the switch is in position 1. So when it is in switch is in position 1, so I will have I naught is equal to 20 divided by 5, which is now 20 divided by 5, which happens to be 4 amperes. Again similarly, when you want to find I of infinity, which is when the switch is in this condition, it is 40 by 2, it is 40 by 2, which happens to be 20 ampere. Then in case of tau, which is nothing but L by R, so what is L? L is equal to 0.5. R is the resistance that is applicable when t is greater than 0, and that is equal to 2. It is now 2. So 1 over tau is equal to 2 by 0.5. So which happens to be 4 now. Which happens to be 4. So what we'll do now is we will try to write the expression for I of t. So I of t is now equal to, so I infinity is 20 plus, so I naught is actually, now this is, okay, I have it as I naught is 4 minus 20 into e power minus t by tau. Okay, 1 over tau is equal to 4. I can write I of t is now equal to 20 minus 16 e power minus 40. This is the expression for the current that is flowing in this particular. So because when t is greater than 0, this will come out here. The effective resistance is R is equal to 2 ohms, and then of course the value of L is 0.5, and the value of I of t is now given by, so I infinity is 20 ampere, because I infinity is the current that we want to flow in this particular setup where you have a 40 volt and a 2 ohm resistor. Now this will be treated as short circuit. We're going to have the I of t expression as 20 minus 16 e power minus 40. Okay, let us try to understand how do we solve this particular problem. So now you can see at t less than 0, we will be connecting this, so then we'll be having a current. Suppose let me try to find out what is I naught here. I naught here is equal to 15 divided by 100. 15 divided by 100 is the value of I naught. Okay, now there is no question of I infinity here because you don't have a source corresponding to this. So the expression what I now have is I of t is nothing but what is I naught e power minus t by tau. So I know what is I naught, which is now 15 by 100, which is equal to 0.15 into e power minus t by tau. So tau happens to be L is 90 millihenry divided by 100. So it is now e power minus t into. So now let me just try to find out what is the value of course you can certainly calculate the value of, now this will become 100 divided by 90 millihenry. So this is the expression for I of t. This is the expression for I of t. So this way we can able to easily find out what is the expression for I of t in case of a source free network and in case of a network with some source. It's like a step input. When you connect this to 2, so you're going to have a step input of magnitude 40. So that's why we are using this particular equation. So this way we can able to comfortably solve different problems on RL network. It is simply trying to find out what is the value of I infinity and I naught, looking at the circuit diagram. So treating the inductor as a short circuit, try to find out what is I naught and I infinity depending on the switch position, and then estimate the value of IK.